Okay, good. Now people know what the process is. Okay? We're going to eliminate b. So what I'm going to do is I'm going to multiply the first equation by -5 and the second by 2. Now what people wanted to do, first thing you said, and it would work, I could have multiplied the first equation by -10 and the second by 4 because I'm trying to match up the b terms, right? So if I multiply this by -10, I'll get -40b. Multiply this by 4, I'll get 40b, and the b's will go away when I add the two rows. It's a little easier to use to kind of reduce the 10 and the 4 down to 5 and 2, right? Okay, so that's what I've done. But if you used -10 and 4 or 10 and -4, either way, it would work. Okay, just be careful about your negative signs. So we get, and that's what I'll probably mess up. So watch me. Okay, so 5 times 64 is 320. I'll get -320 minus 20b equals plus 150. Now you don't have to write a plus. Okay? But I kind of recommend it just so you make sure you're really paying attention to signs, because that's where people usually make mistakes. Okay? So that's just something that I kind of recommend, but it's not necessary at all. Okay? Now I multiply the second by 2, I get 600a plus 20b equals -40. Okay? Then when I add these, if I don't hurt myself in the meantime, the b's are going to go away, right? So I just do first equation times plus second, and I get 280a equals 110. Okay? So that a equals 110 over 280, which is 11 over 28. Now many of you will want to go directly to your calculator and start punching buttons at this point because you don't know what to do with 11 over 28. I want to see you do the fractions. Now if you go to your calculator and do it, it'd be a fairly minor penalty, but there'll be a penalty. I want to see exact results. Okay? And then approximate. That's the basic idea in this course, unless I say otherwise. Okay? Exact, then approximate. And there are good reasons for that. Just digressing for a second, I noticed that people can take rational expressions where we have a polynomial over polynomial and a polynomial over polynomial and add them, get the common denominator, and get everything right. But can't add 2/3 and 3/4. I've seen many examples on the major quiz of people who couldn't do the fractions with numbers but did them fine with all the symbols. Okay? So you got to know how to do fractions with numbers. That's one reason. The other is the basic principle. You get exact solutions, then you approximate, because sometimes your solutions are very sensitive to your approximations, and you don't really know how to deal with that at this level. Okay? I mean, there are intuitive ways you can deal with it, but you really need multivariable calculus before you really know how to deal with it. So unless you want to learn multivariable calculus and verify, yeah, everybody's shaking their head. No. Yeah, I agree. Someday maybe. An applied calculus course has a very good introduction in the second semester to multivariable calculus, as it would be applied in most situations. So whether you do the engineering multivariable calculus or an applied calculus course, many of you are mathematically adept enough to do that. Okay? So if you find that you are, I recommend it. Unless you're very sure that you're never going to have an advantage from knowing it. Okay? But don't take it if you know you're going to fail it. Okay? If you come out of this course with an A or B, you're capable of doing an applied calculus. Okay? And some C students have done it, but that's where it gets iffy. Okay. And C isn't a bad, making a C in this course is not a bad thing. Okay? It's still a feather in your cap to get through it, because most people don't. Okay, so here we got it, right? Okay, so let's see what we do with this.